I'm CK. Tonight we've got another new module from Neutral Labs, new in January of 2023 when I'm recording this. This is their Pip. It is a CV generator and CV recorder. So that'll be interesting to mess around with. Should be interesting modification source for various things. Put it together and see how it goes. Hope you enjoy the video. Here's the box. Pip from Neutral Labs version 1.1. QR code for the build guide, which we'll get to when we start putting it together. Let's open the box up. And a static bag. It looks like it's got a chip in there, but it's in kind of a funny carrier. That's interesting. Got some plastic or paper packaging, which I like, very recyclable. Ooh, look at this. Look, it's a little pin. It's a little dinosaur-y kind of pin. Well, that's nice. I don't know where to put that. I don't have a pin banner. Maybe I'll need to make one of those. Huh. Power connector. Neutral Labs sticker. Another sticker. It's all good, even though I have lots of Neutral Lab stickers. Get the box ready for recycling. Now let's see what we got in here. Let's look at the front panel first. Pip, Morph, A, B, 1/2, 3 halves, 1/4, 2/1, PGA, PGB, sync, record. That looks like LED see-throughs. I don't know what these are going to be. I don't know whether these are all jacks or not. Out, CV, CV. So that looks pretty interesting. And again, these are little transparent panels for whatever LEDs are on the motherboard, I'm sure. I mean motherboard, on the PCB, which is in here. Let's unroll this, and like the Nigel that I did the other day, most of it is surface mount already installed. There is one chip, that one that's in the electrostatic bag, which we'll find. Power connector goes here. And just a bunch of normal components. Let's see if I can read these. LM 3240G and 3240G. I know what that is. I just can't remember right at this second. I'll look it up. And on this side we've got, looks like 3 pots and jacks. Oh, then there's diodes that we're going to actually solder on. And then 8 more jacks. So it's just putting the connectivity components on and the pots, which is not going to be a whole lot of work, is it? In here is going to be all those bits and pieces. Let's see if I can open this bag. Dump all the stuff out. Oops, LED tried to jump out. So we've got knobs, jacks. There's a, this is a 3D printed part. Looks like that's what the LEDs are going to go in. I'm speculating right now. It's a little bit, what fell over there? I just heard something fall over. Don't fall over. Oh, something fell off the carousel. There's a little bit of sprue residue from the 3D printing in the holes, but nothing to worry about. And there's a little red, I guess that's a button cap thingy, but I don't see any buttons. There's the socket for the IC. Actually, I don't know what these are going to be. Oh, here's buttons. Button, where do the buttons go? Where do the buttons go? Oh, they go here. There's 1, 2, 3, 4 switches. And that's the switches that poke through here. Okay, that's pretty neat. 2, 3 white LEDs, maybe. Let me see what color they actually are. I meter out. Continuity mode. And we will see what color these LEDs actually are. Spread the leads out a little bit so I don't screw up. That's green. See if they're all green. Yep, looks like they're all green. Okay. So that's what we got. Again, it looks like a pretty straightforward kit. And let me get the soldering out. Oh, I'm going to open this bag up. Never mind. I almost got ahead of myself. In here, this is a... It's also in a... It's a kind of weird kind of thing here. I don't know whether this is another component or was just to carry the thing. I'll look up in the build guide and see. And this is, oh, the pins are pretty bent here. This is a Atmel Tiny 85 2139 Papa Charlie 0. Maybe it's a microcontroller, but look at how bent those pins are. Gonna have to straighten those out. Let me straighten those out right now. Using needle nose pliers makes the pins straight and also keeps them parallel with each other. Okay, that should be good. Now I'll go ahead and get the soldering iron heated up and we'll put this thing together. The Tiny 85 is in fact a Atmel microcontroller. These are op-amps, quad op-amps. And the first thing we're going to do is find my solder. And there it is. There's a big long piece. Might be enough for the whole kit. I don't know. Actually not. There are too many components. We're going to start by putting the chip socket in for the microcontroller. One leg done. Oh, the board is, as usual, good quality, all through-hole plated. It's not quite flat, so let me heat that up again and get it flat. Now we'll put the power pin header on, and it is not keyed, so it doesn't matter how you put it on. You do want to have it flat on the board, of course, just for neatness. Just for neatness sake. Let me double check that. Yep, that's fine. All those pins go on. Now we're going to place all the switches on. We're not going to solder them yet because we're going to want to make sure that everything works well, because again, once we put the caps on, we want to make sure everything pokes through the front panel right and there's no binding. So we'll just push them in for right now. Fortunately, the way these are designed with the little bent legs, they're not going anywhere. You do have to make sure that you don't accidentally bend a pin under or out. It's easy to do that sometimes, and you won't notice that you've missed a leg. Hopefully you'll notice it when you start soldering it, but better to catch it even before that. And now we've got green pots with little anti-rotation tabs on them that we're going to nip off. onto the floor, because after every project I vacuum the floor, because that allows me to not worry about it when I'm actually working. Yeah. Trying to get this all flat. There it is. Now we've got, not sure how exactly, okay. So RV2 and 3 are the green body ones. And they go here and here. And then we've got a blue body here. Come on. Ah. These pins are a little... The securing pins are securing it really tightly, which is nice. Now we're going to drop the LEDs through. Amber one goes in D3. Now these are not all the same LEDs. The one I called green is actually bicolor, red and green. I just wasn't varying the voltage. They're a little milky versus the white LED, which is really clear. The white LED also, as you can see, has shorter legs. So we'll do D4 gets a bicolor, if I can actually get it in there correctly. D2, which is the white LED, and then a bicolor. Now all of them are positioned the same way, so when we look on the bottom, long legs should all be on the same side, and they are. Now we're going to put the LED holder over them, like so. This keeps bleed from LEDs where it should be, so coming through the front panel, you're only getting one color. You're not being confused as to which color it is. Now we're going to put the button caps on. And we've got 2 gray caps. They go on switch 1 and 4. And again, try and get these as straight as you can, because you don't want them binding through the panel. Then the red one goes on switch 3. And the white one on switch 2. Oops, and of course I knew that was going to happen. The little LED cap thing came off while I was doing that, and it went over here. So I got to go dig it out from over here. Where'd you go, little cat? There it is. Actually, I'm going to leave that there for the moment. Actually, no, I'm not. Oh, by the way, you put the small end down and the broader end up. Now I'm going to set all the jacks in place. And now we're going to go ahead and put the front panel on. Get everything lined up, get all the buttons through, and I'm going to put panel nut on this pot. The author of the kit would like us to put all the jack nuts on too. I'm gonna think about that after I get these 2 pot nuts, because the pots are not going anywhere because of the support legs so I can put the panel nuts on rather firmly without worrying about pulling them up off the circuit board. But I'm going to take a look at the jacks and see if they're, yeah, see, that's not quite what I want to do, because there's a little springiness there, if you can see a little springiness. So what I'm going to do is I'm going to solder this jack in place, holding it with my ring finger behind the board, on the front of the panel, so I can make sure it's flat on the board. Oops. Yeah, that worked out well. Now I can use a panel nut on that jack, which will, since it's secured with solder, it'll make sure it pulls the panel down flat on all the jacks, so they're all going to be flat to the circuit board and not rattling or anything like that. I'm going to test the buttons, make sure they're not binding. They are not binding. That's good. Now I'm going to solder everything except for the LEDs. I'm going to leave the LEDs for a little bit because we want to make sure they poke up against the front panel. But let me get all this other stuff soldered. Oh, there's a lot of surface mount components on this board, and they're near where you're going to be soldering, so be very careful with your soldering iron. You do not want to brush or touch the already installed surface mount components, because number one, you may damage them. Number two, and probably more importantly, you may move them a little bit off their pads accidentally. You may not even notice you're doing it, and then that would be bad because things won't work and it won't be very obvious why. So just use good solder tip discipline to make sure you don't bang up against any of these diodes or resistors or caps, because if you do, you will be sad because you'll be troubleshooting it and you won't even know where to look. Again, lots of little resistors right near these pins. Now we can do the LEDs, which are a little hard to tell. He does emphasize that you want the legs to be at 90-degree bend while you do this to make sure you've got the LED directly below the panel and the LED shroud right. And it's kind of hard to tell, but you can kind of tell. And quite frankly, I'm not going to stress about it that much. I'm going to put the microcontroller in. It's got a notch and a dot. It should fit right in. And it did. By the way, this comes pre-programmed, so you don't have to worry about that. Now I'm going to put the power connector on just because I don't want to flip this around more than once. Power connector goes on like so. Now I'll put the rest of the jacks on and the knobs. Panel nuts and the knobs. And that is that. Knobs all work smoothly. Buttons press well. It's the front. It's the side. It's the back. the other side, top, and the bottom. Now we'll put it in the rack and play with it. Alright, we're up and running. Let me bring the oscilloscope up. And let's go over real quickly what this does. In the Tiny 85, in the microprocessor, he's loaded a whole bunch of waveforms. There are 16 pages of waveforms for each side, and each page of the waveform holds 3 waves. So you can pick lots of ways you want, lots of different waveforms, obviously, that's what we're saying. Right now I've got 2 different ones. The B output is the magenta, the A output is the yellow, or if you're colorblind, I appreciate that. The top one is the B, the bottom one is the A output. B sets the clock rate. So if I change that, you can change by, say, tapping on the sync button. Let me reset it. There, now it's gone a little faster, as you can see on the scope. Now, when I turn the div, watch the bottom trace, and you'll see now we're getting 2 pulses on A for every pulse on B. Now we're getting more, now we're getting more, now we're getting a ton of pulses on A divided out of B. So that's basic. That's the basic thing. I'm going to bring it back up to 1:1. Now when I do morph on B, that's going to change the wave. It's going to a different waveform in the wavetable. Now as you can see, it's a peak and slope off. All the other way, it's just a straight, it's a slope on and sharp off. I'll put it somewhere like there. Now if I do the same with A, we can see we can have different waveforms. There's only one clock on B. The waveform simply has more peaks. I'll move to A around a little bit more. Now I'm going to hit the page button and we will look at the top line. Now we've got another wave, another page full of waves, and that's the waveform now. Oh, let me bring up the sound again. I'm just poking the poking one note, so you just have a little audio version. Now I keep moving through the pages. You can see how that slopes off differently, and look at that. Now we've got a little saw. Now look at that. That's an interesting waveform. Let me change the A output waveform table and roll through those. Those are the waveforms available there. I'm going to poke a couple more times and see, look at that. Got a lot. That's a nice, almost smooth ramp with a top peak. Go to the next page. There's a nice sinusoidal type wave. Now, as you may be able to tell here, we're going from 0 up right now because I'm in the top outputs. If I go to the bottom on A, you'll see now instead of 0 to 5 volts, now it's -5 to +5, roughly. So you can have audio style negative to positive, or you can have flat, only going positive. Same with the magenta line. As you can see, the top line now I've got it going -5 to +5. Let me play around with that one a little bit. I like that peak, peak, peak thing. I'm going to take A down. I'm actually going to plug the audio output into here. Hear what that sounds like. If I'm getting anything, it may be too low. Okay, so that's the A output as a wave, as an audio wave. And you can see I'm speeding it up, slowing it down. Now that's interesting. I just noticed that as it goes from page to page, there's an audible click as it changes divisions. Hear it there? You can see it on the scope too. I'll turn this up a little bit so you can hear it better. Only when descending, only when slowing it down. Oh no, I'm wrong, it's up too. So just be aware of that. When it changes division, when it changes clock on A division-wise, there's going to be a little click. There's a discontinuity that you'll pick up in the CV output, whatever it's going to, whether it's going to an audio source like this or something else. Let me switch back to what I was. Turn that down. So now again, and I got to remember what the heck I'm plugged into here. That's the B waveform. That's the B waveform setting the CV into a VCA. Now that's from the bottom. Let me go into the top, which is the unipolar, which is going to be more accurate for VCA. So that's really handy. Now I'm going to grab another cable from somewhere. I'm going to go from the A waveform into frequency modulation on this even VCO. That sounds pretty neat. I'm going to rotate through waveforms now. Change page again. Different waveforms there. Now again, that's -5 to +5. I'm going to go 0 to 5 now again, because that's more appropriate for frequency modulation input. Now let me change divisions again. Rotate through the waveform. Switch pages. Switch pages again. Oh, look at that. That's an interesting waveform, isn't it? I'm going to slow the div down so we can look at that better. Change pages again. So that's what it's doing. I'll turn that down again. So that's what it's doing. There's a bunch of stored waveforms. They come out. The top one, you can't set divisions. That's set by the sync button. Let me let it go real fast. See if I can. Now you can see I made it quite a bit faster. The B side, the A side, you can change the divisions or make it exactly match. And what that means, if you have it on one, that means you've got two of the same waves going out from both sides, so you don't have to use a multi or something like that. You can just use this and get the raw waveforms in. Now, what I'm not going to test is I'm not going to test recording a waveform, because I don't want to do that right now. You can also, let me take my LFO that I have here and find another cable, which I can never... I'm going to take, can I go out? I'm going to go from my LFO to sync CV. Oh no, I'm not there. I'm in the wrong place. Okay, that's not doing what I expected it to do, but that's okay. I'm not going to mess with that. I'll figure that out later. But again, this is a real cool unit. So, by the way, when you record something, it replaces one of the waves in the page you're on. And then you can reset that too. He describes how to reset it. But this is very neat. I mean, you've got a lot of waveforms at your fingertips. You can do lots of interesting things with them. Switching them all around. I just slowed it way down. And so on and so forth. This is a real good unit. This is really going to be fun, both for any kind of modulation, whether it's frequency modulation, whether it's cutoff ranges for filters, whether it's, because I can do this too. Let me do this for fun. I'm going to change my, well, that flattened it right out. It's not high, it's not doing what I want it to do. But that's good for the, oh, I know what I did wrong there. Never mind. What I want to do now is I'm going to take this waveform, the B waveform, and now it's going into my volts per octave and creating a variable tonal output. Let me slow that way down, even though I may not be able to get it slow enough. And I'll take the frequency modulation out so you can just hear it sweeping through audio frequencies there. And if I go lower, that won't do the right thing, because since that's -5 to +5, half of the CV I'm sending to the volts per octave is being thrown away because it's negative and it doesn't have any value in the standard for eurorack. But all in all, this is a really good unit. I like it a lot. Obviously, it was pretty quick to put together, but what it does is really neat. I highly recommend this one. And I hope you enjoyed the video.